This conference will now be recorded.
Okay. I just have to make sure. Okay. This screen, I'm trying to minimize this screen. Okay. All right. Why this screen is not going? All right, no worries. I'm just getting some extra screen on my this GoToMeeting screen, which I'm trying to minimize, but it is not happening. Should not be a problem. I have to find another alternative. I have taken it down. Okay, so fine, fair enough. I made the adjustments. So guys, welcome to the future. In fact, the future which I have written over here is no more a future. It is, of course, it is the current. So I should say welcome to the present. Present, which is called Cisco ACI, which is nothing but which is SDN solution by Cisco. Everybody knows about it, but acquiring the knowledge of it is very important. This is nothing but this is, I'll say, old wine but in a new bottle. That is, the old classical traditional way of configuring the network is going to be a different way of configuring the network. What is this? This is what our journey is. In this particular journey of us, we are going to look at into a lot of old stuffs, a lot of new stuffs, a lot of old terminologies, a lot of new terminologies. Yes, wherever new terminologies are going to come, we will be talking about those new terminologies in detail. Expectation is you guys need to know the basics of routing and switching, which I'm sure everyone knows it. So we are going to look at into lot many new terminologies in this particular journey. What is ACI? ACI, which is nothing but Cisco's version of software-defined networking. ACI stands for application-centric infrastructure. ACI is nothing but it is a way of configuring the network, not by device basis, but with the help of one single point, which is called controller. The question is, why ACI? Why ACI? Because ACI is giving us many tons of solutions, a simplicity. Guys, let me tell you, probably I am doing marketing. My intention is not to do the marketing of the product. My intention is just to teach you the technology over here. So far, this has become our status of the network operations. A person who is an operation engineer, he is loaded with tons of requests, tons of information, and it becomes very difficult for him to arrange. So what does ACI typically mean to a network administrator? Guys, if you take a look over here, one gentleman on the left hand side is an ACI expert, and other gentleman on the right hand side, he is a typical network engineer. The gentleman on the left hand side says, I do understand ACI as a 3-tier application model. And when we as a typical network engineer hear of this term 3-tier, we say, oh, this is a 3-tier architecture he's talking about. But guys, the ACI is not a 3-tier architecture, that is core, distribution, and access layer. No. ACI, okay, if I present ACI to you in the form of an application, 3-tier application, then it will be wrong, because an engineer need to understand first of all ACI in terms of the devices. Where are the devices? How are the devices placed? So if we look at into the devices, the placement of the devices, before that there is a simple question. That is a question of SDN software defined networking as with regards to a solution which is network centric solution and a solution which is application centric solution. Guys, this ACI can be implemented in two different ways. Implemented in a way of network centricity and implemented in the way of application centricity. When we say that it is to be implemented in the way of network centricity, this means that ACI fabric, I'm going to tell you what is this fabric. ACI fabric will provide us not only the connectivity platform, but also the platform for servers wherein the servers will be connected to the ACI fabric directly. Okay. In case of application centricity platform, well, what's going to happen in this particular case? The configuration what we will do in servers, we will be doing the configuration in terms of a terminology called EPG, wherein our focus on EPG will be to cater to the need of various applications running in the data center. I know this is theory, but we will be doing this in our practicals. Very practically, we are going to look at into this. So we will be taking a practical look on network centricity and application centricity. So I really need to take you guys towards how ACI at the initial phase looks like. So would just like to tell you the connectivity in our ACI fabric. In our previous topic called VXLAN, we said it is a leaf and spine architecture. It is a layer to loop free architecture what our VXLAN fabric provides us based on the formalized structure given by Edwin in the year 1938, by clause in the year 1953, adopted by Bell Telephone Company the same year 1953. So the architecture which ACI is going to use here is not a new architecture. It is a very old architecture. This architecture is called a leaf and spine architecture, which we have seen in VXLAN. However, not many configurations we did in case of VXLAN to create that particular architecture. Okay. If we compare our ACI, okay, with our traditional network, in traditional network, the configuration is on per device basis. That means if we have hundreds of devices, then we need to log in into each and every device individually and do configure the device using the CLI. ACI says, don't simply worry about it. In a data center wherein you have got hundreds of devices, I'm saying 100 of switches, you can configure all these hundreds of switches from a single point, single management point, and that is called controller, and not with the help of CLI. The traditionally what we do in case of our traditional setup, but with the help of GUI, with the help of our automation and all. So old fashioned, let's say goodbye to old fashioned and let's go into the new fashion. Let's put the old wine in a new bottle. Thomas Edison said, there is a way to do it better. Let us find out the way. So in ACI, we do things differently. So when we say do we do things differently, then we have a different new terminologies involved over here as well. Some of the terminologies are known to us already. Some other new terminologies are going to be included. I'm not going to explain you the terminologies right now, but definitely these terminologies and their understanding is integral part of our knowledge, without which we cannot do that. For example, one of the most important terminology is this one. In short, we call it as AAEP, Attachable Access Entity Profile. A big question comes is, what is this? I have seen even in CCIE data center theory exam, qualifying exam, not many questions being asked from what is AAEP. So this is a star terminology, I should say. Then we can see a lot of other terminologies. What is a switch profile? Bridge domain. Bridge domain, what we discussed in VXLAN, guys, we will not be confusing that particular bridge domain with this particular bridge domain. This is different. This is not the bridge domain what we talk about in case of VXLAN and specifically for Nexus 7K switches. No, it's not that. Some similar terminologies, but they are indeed different. We have we are going to have a new terminology called EPG, endpoint group. What is this? We will be looking at into a contract. It's a new terminology, but it is similar to that of access control list, which we have created in our firewalls, in our routers. Another terminology called filters, which is going to be associated to the contracts, subjects, etc. and all. Over here, subnet terminology, it will be different as the subnet we do understand. So we will be looking at into these terminologies slowly and slowly. All right, coming over to ACI networking. Hope you can see, guys, the topology. This topology wherein we have the switches at an upper layer, where we have switches at a lower layer. It is just a two-tier architecture, right? We officially do not call this architecture as two-tier architecture, but we call this architecture as leaf and the spine architecture. Leaf and the spine architecture. In this particular architecture, it is just our north to south connectivity. There is no east to west connectivity. I'm sorry. That means the lateral connectivity is not there between the spine switches, the leaf switches. Similarly, no lateral connectivity, which provides us, which blesses us with a absolute layer 2 loop free topology. This is what we did in case of VXLAN. Now, in case of ACI, the topology wise, it is same. But in case of ACI, in order to configure these switches, the spine switches, the leaf switches, we do not individually log in into them, but we do configure them with the help of any of this device called controller, application policy infrastructure controller, which normally in production environment is placed in a cluster with minimum 3 nodes. This is known as controller, and with the help of the controller, we log in into the controller and we do the configuration on for all the devices. This is a beautiful way of configuring. So this is what we are going to see. With regards to the spine switches over here, that is the upper layer. The spine switches are our Cisco Nexus 9000 series switches. Of course, they have to be the upper layer 9000 series, wherein 9504, 08 and 9516. There are certain 9300 series switches which do qualify as a baby spine switches, and these switches are 9336PQ and 9364C. Hope you remember the very first day Nexus hardware class, we had a detailed diagnosis of our Nexus 9000 series of switches. At the bottom layer, that is below the spine switches, we do have the Nexus 9300 series switches. Various models are available with regards to them. Some of the models I have mentioned over here. The detail of which you can obtain in any of the Cisco Nexus 9000 series data sheet. The way the management options, multiple management options are available. You can configure it using GUI, which is number one, topmost way, the initial way to configure it. This is what we will be doing it. You can configure the switches. CLI, not at all recommended. CLI is normally used for the purpose of troubleshooting, wherein you can log in into each and every individual switch to look at into how the traffic is flowing. In case if any issue is there, Cisco ACI tech team actually works at the CLI level to troubleshoot. Our course is not a ACI troubleshooting. This particular course is ACI implementation. So when it comes to ACI implementation, we have to look at into the very first point of implementation way, which is a GUI way. Of course, we will start from CLI to create our initial setup, but not on the leaf switches, but our initial setup using CLI will be on our APIC controller. I will show you how do we do it. XML, JSON, other scripting languages, open application programming interface and automation, lot of ways are there. But the number one way is GUI. Once our fabric is ready, with the help of our GUI based configuration, only then we can go for multiple other ways of configuration. Okay. All these, what I'm saying, guys, is I'm sorry to say that I'm explaining you theoretically, but it's all practical. So definitely we can come back to it. Graphical user interface on the very left hand side, you can see. This is how we are going to configure our fabric. This not only helps us to configure, but also helps us to monitor, also helps us to look at into the graph, connectivity graph of various devices. What does this mean? That the moment we'll start configuring, it will start creating the topology. Any moment, any point, once your configurations are done, to verify whether the configurations are correctly being done or not, guys, you can take the help of this topology graph, which gets automatically created. Not only this, our configurations are correct or not gets also reflected in something called health score. So it also helps us, health score also helps us to understand whether our devices, whether our configurations are healthy or not, healthy in terms of whether they are meaningful or not. Guys, the very first thing when it comes to health score is we are, before starting to configure our fabric, the very first thing we need to check is the health score of our APIC controllers. Say APIC 1, 2, and 3. I'll tell you that unless and until we happen to see that our APIC controllers are healthy, we there should not start doing the configuration. Guys, in CCIE data center version 2.0 exam, question number 4.1 was on this only. This was a question wherein the question asked the candidates to fix the controller issue, wherein one of the controller was not in a healthy state. So unless and until you do this particular, it is meaningless to go to other sections and other subsections. So very important, we will be taking a look onto how to look at into the health score of our controller. Then there is CLI way, but as I said, CLI is predominantly used by Cisco ACI tech team for the purpose of troubleshooting. I will interact you with the CLI also, that how this CLI looks like, what are the basic initial commands. With the help of CLI on the leaf and the spine switches, guys, we will reach on to the ASIC level. ASIC chip level, wherein I'll show you that there are two ASIC chips which prepares the database tables. One is called Broadcom ASIC chip, BCM, and other is called North Star ASIC chip. We will be taking a look on the purpose of these ASIC chip in our very first lab called the very second lab called bare metal host, because our very first lab will be with regards to the APIC controllers, to make sure that three APIC controllers, they form one cluster, that all the leaf and the spine switches are well discovered and configured. Rest, post, there are scripting ways using your automation, Python, Ansible, Postman. We can also configure our fabric. Guys, once your fabric is configured, ready for the first time, the next time onwards, we do not return back to our GUI again and again to do the configuration, but we download a script which our controller creates. We export the script, and this entire GUI is exported in the form of a scripting, and our task will be to just make the modification in the script being downloaded, being exported from our controller, and just to make the changes in the script and run the script back onto the controller, which will make sure that all the configuration are pushed back into the fabric. This is what is also called automation. So this is going to be our last topic, wherein we will be learning the Python. We will be learning the Python script. And guys, let me tell you, we will be learning just the primary language, the primary and basic understanding of Python, having various kind of statements. We will be learning the Python operators, Python strings, conditional statements, iterative statements, and all. But our intention will not be to become a full-fledged Python or network automation expert. Okay. APIC is what? Number one, APIC is a controller, is topology management controller, provides us a health score, helps us to provide tracking and troubleshooting, traffic maps and statistics, provides us inventory, provides us a logical view, as I said. So our dear APIC controller is basically a management and a tool which helps us to understand the topology. Since we will have hundreds of devices in our fabric, it will be very difficult to and complicated to prepare the diagram. So APIC helps us to take a diagrammatic view of the entire fabric. Okay. APIC controller can be integrated with many other devices. Dear friends, in our second last lab called Hyperflex, I'll show you how you can add plugins. Plugins where in your vCenter server. What for? To manage your APIC controller. That is the configuration which you do from the APIC controller. The configuration you can also do from the vCenter server, VMware vCenter server. How? By adding certain plugins. There are plugins in VMware vCenter server for the purpose of Hyperflex also. So we will be learning to use those plugins. So there are various VMware tools, like we have one vRealize automation, we have orchestration and all those tools, and we can manage our controller with the help of those VMware toolkits. OpenStack is another way. ServiceNow, probably if I'm not wrong, this is IBM tool with the help of ServiceNow, UCS Director, which is an orchestrator. can be managed, and Windows Azure APIC. So we do have the plugins with regards to all these tools. With the help of these tools, we can manage our fabric as well. Okay. Now, ACI building blocks. As I just told you, the main devices forming this particular fabric, number one, switches. Which switches? Only Nexus 9000 series switches. And the Nexus 9000 series switches which are loaded with ACI based operating system and not NX OS, because we know that Nexus 9000 series switches, they do come along with our NX OS. In VXLAN lab, we worked on Nexus 9000 virtual switches loaded with NX OS and not loaded with ACI operating system. Our ACI firmware is different from that of our NX OS firmware. There are certain Nexus 9000 series switches which can be installed both with Nexus operating system or ACI operating system. There are certain Nexus switches which do come only along with ACI operating system. The Nexus OS Nexus 9000 data sheet by Cisco can provide you this. Now, these switches are connected in leaf and spine topology we have seen. The another component of this particular ACI fabric is APIC controller, stand for Application Policy Infrastructure Controller. Dear friend, this is just the schematic presentation of APIC controller, right? This is not how the APIC controller looks like. I'm going to show you what is APIC controller. We are going to look at it in detail what is APIC controller, what is outside it, how it is connected to. So Nexus 9000 and APIC controllers combined together gives us ACI, which is called a complete fabric. So APIC controller, Nexus 9500 and Nexus 9300 combined together gives us ACI fabric. And the lab, one of us very small lab, which we will be working upon, is going to be this kind of lab. The lab on fabric discovery. In the very first lab, we are going to have 2 spine switches, 2 leaf switches, and 3 controllers. Dear friends, let me tell you the name of the lab. The name of the very first lab will be the fabric discovery. What is the objective of this lab? The objective of this lab is the lab will be given to you with all the connectivities, that is physical connectivities between the spine switches, say spine 1, spine 2, leaf 1, leaf 2. Physical connectivity will be done. These blue lines will be drawn. The APIC controllers will be connected to the leaf switches. Hope you can see that APIC controllers, they are connected only to the leaf switches. Our objective will be that none of this device is configured. In terms of say IP addresses on these interfaces, their loopback interfaces, nothing is being configured. Just that we, by logging into these switches, which is not mandatory also, we have just specified the management IP addresses and just the management IP addresses, and we have made sure that these all the devices, they are now participating in the management network. Configuration wise, nothing is being configured. In the very first lab of ours, which is called fabric discovery, the very first, say this particular controller will discover one of the leaf switch and will register it, and then the spine switches register and the other leaf switch register. Once all these devices, that is the spine and the leaf devices, they are discovered, first is discovery, and registered. Once it is done, guys, then what is going to happen is these three different nodes called controllers, they will form one cluster. And how do we check it? That we can log in into any of the node, and we'll see that node 2, node 3 with their IP addresses, they are being discovered and they are in healthy state, healthy, and this is called fully fit state. Once the clustered nodes are in a healthy and in a fully fit state, only then it makes us sense to start configuring. So the very first thing is fabric discovery, followed by cluster formation, and once it is done, then the third thing that is called configuration comes. Sometimes, you know what, because to us this lab is, this portion is given, this portion is given, and we just start jumping over to configuration. No, this is not the way we are going to do in our classes. Okay, so 9508, I have already presented 9508 to you in the very first hardware class. Dear friends, if you have any question, any doubt, anything you want to repeat, recall with regards to Nexus 9500 series switches, wherein we have got three different models: 9504, 9508, 9516. Feel absolutely free. There is Cisco 3D interactive catalog available in Google, both in downloadable version as well as in a web version. Cisco 3D interactive catalog, right? Hope you remember we had a discussion on it. You can go through Cisco 3D interactive catalog to understand the inside of the 9500s series switches. Hope you remember while talking about 9500 series switches, we said this is a beautiful chassis with no mid plane. Hope you remember I told you that this, in this particular chassis, if we remove all the line cards, the fabric modules, the system controller, the supervisor engine, the fan supplies and power units, the chassis is absolutely a blank chassis. Okay, I just would here need a little pause so that you guys can feel comfortable. The reason is, guys, just a second. Okay, guys. Okay, so okay, 9500. I know, in case who all have joined me for the first time, you know, probably I have got some of my friends who have joined probably for the first time, and yes, Kumar, Vikram, just passing. Okay, guys, no praises. I know. In case if you have any doubt, any question with regards to Nexus 9500, I will give you a separate explanation of Nexus 9500. Okay, back. Nexus 9300 family of switches. In this Nexus 9300 family of switches, we need to understand them from two important angles. One is with regards to the interfaces. My pen. You can see there is a GEM module over here. This is called GEM, Generic Expansion Module, in 9396. Similarly, in 93128TX, this module is our GEM module. Please take a look on this yellow highlighter highlighting the interfaces. What does it says in Nexus hardware classes? We spoke. They are talking about these are 40 gig interfaces. The interfaces which you do see over here on the fixed module, these interfaces are our 10 gig interfaces. The same applies with 93128TX, just we have got it as a double decker fixed module, double the port density. However, this particular switch also has got a generic expansion module. Guys, this is very important. Why is it so? Because this, with the help of this particular module only, the device, this leaf switch, this is a leaf switch, is connected to the spine switch. Say spine 1 and spine 2. What am I trying to tell you is the leaf to spine connectivity is always 40 gig connectivity. These interfaces are the interfaces which are meant to be connected to the servers. So our leaf switches to servers, the connectivity can be, minimum connectivity speed could be 10 Gbps. So minimum speed between leaf and spine switches is 40 Gbps, and minimum speed between our servers and our leaf switches need to be 10 Gbps. Dear friends, let me tell you, using these interfaces only, that this particular leaf switch is connected to a server which is known as our application policy infrastructure controller. Yes, what I'm trying to tell you is our APIC controller is nothing but it is also a server. What server? We will be talking about the Cisco servers called UCS, Unified Computing System servers. So this is one of the model of Cisco UCS server, which is embedded with the APIC firmware. Well, ACI ordering guide. This is just a Cisco tool in case if you are entitled a responsibility to order the ACI fabric and the devices, you need to look at into this particular data sheet. Okay. The fabric, the scalability of the fabric. How many maximum number of spine switches? How many maximum number of leaf switches? How many maximum number of APIC controllers? But when we talk about ACI fabric, let us talk about the maximum number of leaf switches, spine switches, and the hosts. Guys, based on the version, current version running is 4.5.4 if I'm not wrong. This is the version of the controller. Based on the progress in the version of the controller, the number of the leaf and the spine switches have increased. So this number of leaf and spine switches is not fixed. This is based on the controller version. So in case if Cisco upgrades the version, more leaf and spine switches could be added. What we can say is maximum number of leaf switches is 400 per fabric. That means over here, we are so fortunate, guys, we can have 400 leaf switches. And how many number of physical ports? 19,200 per fabric. This is one fabric. So total number of physical ports connected to the physical servers downstream below the leaf switches could be 19,200 ports. The maximum number of spine switches in one single pod could be 6 spine switches. Total spine switches in multiple pods could be 24 spine switches. Guys, we are talking probably over here about multi-pod setup. So multi-pod will come to it later on. Okay, about the controller also I'm going to tell you. This is how the connectivity gets established. These are our spine switches over here. In our lab, the labs, whatsoever we will be doing, we will be using just 2 spine switches, a maximum of 4 leaf switches we have, and 3 APIC controllers. That depends on what lab we are doing. These leaf switches, they are qualified as different names. We can call them as border leaf. We can call these leaf switches as server leaf switches. Say server leaf. It is by the virtue of the device they are connected to, they do get those names. One leaf switch may not be dedicated to just for the border purpose. Okay, what is a border leaf? A border leaf is a leaf which is actually connected to either layer 2 or layer 3 external devices, that is the devices which are not participating inside the ACI fabric. These devices, they belong to a traditional setup, traditional network, but they are connected to the ACI fabric. So leaf switches which help us to connect to the non-ACI fabric devices are known as border leaf switches. The leaf switches which help us to connect to the servers, they are called the server switches, server leaves. Of course, there is a VPC which we form. VPC where in the leaf switches. That is one of our small lab, how to create VPC using 2 leaf switches. Similarly, our leaf switches could be connected to layer 2 external, as I have shown over here. Say these are the firewalls, load balancers. Those external devices could be Nexus switches or Cisco IOS layer 2 switches. Those external devices could be our layer 3 routers. Say Cisco IOS running routers or layer 3 running switches, Nexus layer 3 switches. So it is just a matter of how the leaf switches are connected to. Okay. Something which we will be discussing once we are done with our single site ACI fabric configuration is called multi-pod. We will be understanding how this multi-pod setup is created. Multi-pod, as the name says, it is a multiple pool of devices, not only one single pool of device, but multiple pool of devices can be connected together. We will be talking about it in detail. The important thing in case of a multi-pod, as different to that of multi-site, is multi-pod has got a common APIC cluster between the 2 ACI fabrics. So this is one ACI fabric. This is another ACI fabric having leaf and spine switches, but they do share their common APIC cluster. Beautiful it is. However, in case of a multi-site, if you go, you will happen to see that in case of multi-site, let me see if I have a, okay. You will have separate individual APIC clusters. Multi-site configuration is done with the help of a tool called MSO, multi-site orchestrator. We will be learning, that is going to be our last lab of ACI almost by the end of the month, right? It will take us 3 weeks to do the basics, and then 4th week we will be coming over to multi-site orchestrator based lab. There will be a concept of remote leaf, which the lab of which we have not included. Remote leaf is a concept wherein our leaf switches are not locally available, but the leaf switches say these are the leaf switches. The leaf switches, these are the leaf switches, which need to be participated inside the ACI fabric. They are not locally available in the data center or in that particular geographical location, but these are far away geographically, but we can still bring them into our APIC cluster. This is not part of our data center, but this is possible. We can have it. We can have our remote location connected via satellite. We can say there are the satellite data centers, brownfield data centers. That means the data centers which are already established. Now we want to bring them in the same APIC, in the same ACI fabric. Those are done with the help of a concept called remote leaf. Remote leaf concept was introduced in APIC version 4.x onwards. Prior to that, this particular was not there. Anyway, then there is virtual pod. No, that will be. Now, important thing. After having so many detailed discussions, now let's say goodbye to those. Let's come at the ground level. And at the ground level, we need to understand our APIC controller as a server. What is this actually? This particular server is not a server meant for control plane. Guys, here comes a difference between industry, software-defined networking, and Cisco's application-centric infrastructure. In case of industries, software-defined networking, the SDN controller is a server controller, but for the purpose of management plane, that is a configuration, as well as for the purpose of control plane. However, in case of Cisco's SDN solution called ACI, these controllers, they are neither responsible for control plane, nor they participate anywhere in the data path. What are they for? They are just the management controllers, just for the purpose of pushing the configurations. How the configurations are done, how the configurations are pushed, how different protocols they contribute to this, all we will be seeing it. But important thing is, we need to understand these devices as servers for just managing the configuration. These servers, ideally, they are always placed in a cluster of odd numbers, that is 1, which is not recommended in production environment, because if one and only one goes down, we are completely lost to do the configuration. Suppose we have only one APIC node in a cluster, we don't have any other node. All configuration are done, traffic is passing through, and one and only one goes down. Dear friends, I have say that these are not available, right? Forget about that. Only one is there, connected to leaf, leaf connected to spine, spine connected to leaf, and this goes down. What will be the impact? Would appreciate if you can give me some respite and you can speak.
There will not be any impact.
Absolutely. There will be no impact. There will be no impact neither on the control plane nor on the data plane. The only impact will be further configuration, etc. You cannot do. Why? Because controller is lost. In case if controller has lost all the configurations, guys, this is a catastrophic impact, because your network further configuration will not be possible. These now, if we have the 3, 1, 2, and 3 nodes, 3 controllers in a cluster, right? 1, 2, and 3. What is the purpose? Why we are saying that the nodes, they need to be in odd numbers? Guys, probably you have heard of concept called RAID. Why I'm saying probably? I'm sure you all know about RAID. RAID has got various mechanisms. RAID 0, RAID 1, right? RAID 3, RAID 5, RAID 6. In RAID, there is something called striping plus parity. The question from your side should be, why 3? Why not 2? Because the mechanism with the help of which, the algorithm the help of which these different nodes, they distribute the configuration and they sync with each other, is known as sharding. It's not called shading, it's called sharding. Shard means small pieces. What happens is, whenever we do the configuration from any of the controller, it creates small pieces, and or you can say strips, and distribute it into the other controllers. The algorithm is prepared in such a way which says that you require the controllers in odd numbers: 1, 3, 5, 7, 9. So that is the reason. Point number 1 is, holistically, normally we do have the 3 nodes in a minimum 3 nodes in a production environment. In a lab, even if you have a single, because the data plane, control plane is not the issue, you can have one single node. But in case if you are deploying one single node only, there will always be an error message presented to you. Okay, I'll show you where that error message comes. Now, understanding this controller. Dear friends, this controller, as I said, is actually a Cisco UCS C series. server. Okay, I'm just trying to manage this Google Meet small canvas, which does come and is now irritating me because it's taking a lower bottom space of my laptop. I'm just trying to remove it so that even I can take a look on full screen. So guys, this particular controller, which stands for Application Policy Infrastructure Controller, is actually a server, which is Cisco UCS C series server 220 M3 or M4. This is not even 240. 240 is double layer. This is a single RU server having say 64 GB of DDR, 1 terabyte of flash drive, VIC card, software, CentOS software, and basic hardwares. This is the server. Let me show you this particular server from more closer angle, and this GoToMeeting has to go down. Okay, GoToMeeting behaves differently in Windows and in Mac operating system. Okay, so if you take a look on this server, front is fine. We can see a couple of ports. We can see some slots where there are disk slots. Disks are inserted. Important thing is to look at it into from the rear. From the rear side, we can see some ports over here. We can this is a fan power supplies, fan power supplies. Then we have this particular port, a serial port. Next to serial port, we have this particular port. What is this? And then we have got certain ports over here, 3 ports. It's better to look at into this from a more closer angle. So let me bring it more closer to you. Just trying to show you over here the evolution, the release timelines. Currently it is 4.x, which is going on. This is the GUI of, okay, this is the sandbox. I have stopped using the sandbox because it is tremendously suffered with a lot of latency issues. Probably this particular sandbox is provided by Cisco DevNet solution, which we are not using. We will be using, I'm sorry, Cisco D Cloud for the purpose of having our controller access. So from tomorrow onwards, I'll make sure that controller is available. If I book it now, it will take some time. Okay. This is version 4.1 controller available currently in sandbox. Okay. I have already told you about this. I now need to show you controller from very closer angle. Okay. Before that, all right, it is 9 o'clock. Now, I would like to give time to you guys so that you can now ask me any question. It's theory, so I really don't want to give you a lot of theory in a single day. I will present this controller to you, say tomorrow, along with the APIC communication protocols, different control plane protocols, what we have. So let me know if you have any question.
Ashish, one question here. So by default, we have these 3 controllers, right?
Yes.
So as you said, the controller is something just do the management kind of a work, and it doesn't do any data or controller kind of task, right? So what would be the use case if if a person wants to span the controller's number, like from 3 to 7 or 9 or
Mhm.
so yeah.
Okay. Okay. The use case for the scalability of the controller, that is, if initially we have just 3 controllers and now we want to scale to 7 controllers, it depends upon the scalability of our ACI fabric. That means if now in the data center requirement has come that we want to scale our leaf switches, say from 200 leaf switches to 400 leaf switches, to manage these leaf switches, it is recommended by Cisco to have 7 controllers or 5 controllers. So depending upon the recommendation, that is, for these many number of leaf switches and the spine switches, you need these many number of controllers. According to the number of spine and the leaf switches, we have to increase the number of our controllers. That is the simple use case. For that, definitely there is a data sheet available.
Okay.
Okay. Guys, this is your time to ask the question. Otherwise,
Ashish.
Yes, Jay.
Hello. Yeah. So normally 9300 series is the leaf switches model actually. So in that we have 9396. There is one model now PQ. So we will call we can use as a spine set.
That is right. Probably.
So what is the difference actually? How it will differ actually? Basically, to work as a spine actually, because it is 9300 series and we have ACS image only. And in any special feature to work as a spine?
Okay. Yes, absolutely. See, our leaf switches and our spine switches, they have got different firmwares to perform differently. So 9396 PQ, the 9300 leaf switch, 9300 switch is actually prepared for the purpose to run as a baby spine switch. This is called baby spine switch, which means the firmware which we are going to install in it, it is basically the firmware which will perform the spine functionality and not the functionality of a leaf switch. Does it make sense, Jay?
So you mean that the ACI, the image which we are using, that is makes different, is it?
Absolutely. So controller has a different image. Spine switches, they have a different image, and the leaf switches, they do have their different images.
Okay, so in the ACI image itself, the leaf switches will have different image and controller will have different image.
Absolutely. And all these images are installed in the controller itself. So it is a controller which diagnose the leaf and the spine switch and push these images either to the leaf and the spine as the model is there.
Okay, and regarding this APIC, and the cluster mode, so my doubt is whatever in the is it like primary all will be active mode or how it is?
Very good question. Very good question. Yes, all are in an active mode. In active mode, which means you can log into any of the controller to do the configuration. The configuration synchronization happens among all these controllers in a cluster. And using the control plane protocol, they push the configuration onto the leaf and to the spine switches. So short answer to a beautiful question is yes, all the controllers are active controllers.
So they will have auto sync.
Absolutely.
Whatever controllers are using any configuration changes, it will get synced with all the controllers.
Absolutely. And it is due to this particular reason, we need to make sure that all the controllers, they are in a healthy and fully fit state before we start doing the configuration. In case if they are not, we need to troubleshoot why they are not in a healthy state. Okay. Guys, your questions are really very, very important, because sometimes I may skip to tell you something. That point of time, your question really helps. Okay, Harsh, will you show data plane testing as well, or just controller config only? Good question, Harsh. Harsh, I will be using two kind of labs. One is Cisco D Cloud, where we will be doing the configuration, and I will be showing you the data plane communication as well on the real hardware devices, but that will be with the help of my old class videos where I used to cover this in real devices. I will show you the data plane testing truly, but not in live, but using my own previous videos. New friends who have joined, if you have any question, any apprehension about it, let's be very vocal about over here.
And UCS, we have separate module, na, in that, or I mean, it's a separate topic we are going to cover.
Yes. UCS, Unified Computing System, is a separate topic altogether, which we will start after completing our ACI. UCS, and in that particular topic, we would be understanding each and every component of UCS. In itself, it's a beautiful and a big topic.
So it's basically the server, is actually a Cisco server, is it?
Okay. Basically, if you say, I'll say fine. I will not say yes. But UCS is considered to be an architecture. It is not one individual device. It's a complete architecture in which you have fabric interconnects, you have servers, you have other switches participating, then you have got storage controllers and all, storage arrays and all. I'll explain you that. Even in the server, there are different components which we need to understand, like the cards. There's not many components are there. Okay, that is a separate topic.
Okay.
There is a question by Amit. Okay, I have dropped one question in chat box. I have mic issue. Okay, can you brief in more detail why we use 3 and 5? Amit, because there is an algorithm for the purpose of distributing the configuration, and that configuration distribution is known as a mechanism called shard. The shard mechanism, which Cisco has installed, developed, embedded into the controllers, it needs the configuration to be stripped. Say, for example, when we strip the configuration, it is stripped into different pieces. Okay, for this, let me tell you with the help of one example. I just give you a very layman's example to explain. And this is definitely from the concept of our RAID mechanism. If you know about RAID mechanism in redundant array of independent disk, what happens in striping? We strip the data, and for this particular purpose, a very simple thing, if we say. Okay, we all know that A plus B is equal to C. We all know 1 plus 2 is equal to 3. Suppose we know, dropping from call first. Okay,
Hi,
we
sir.
know that this.
Hello.
Yes, please.
Yeah. Go ahead. Yeah, you continue, please. Thank you.
Okay, so suppose if you have 3 variables, 1, 2, and 3, any one variable goes down, right? Suppose if this 2 goes down, then you can immediately say 3 minus 1 is equal to 2. So this component which is lost could easily be derived with the help of a simple equation. The same thing we do say that in case of our APIC controller applies, and Cisco calls it as shard, that is the small pieces of the configuration it does. What it does is there is a configuration, it cuts the configuration into small pieces called shard and distribute it among various controllers, wherein they keep on syncing with each other. In case of any outage with regards to a one controller, immediately the configuration gets repaired into others. So that is the reason Cisco suggested that 137. It's because of the algorithm which they have developed. Okay, and this is the reason, Amit. I'm just looking at into more questions in case they are there in the chat window. Well, we really need not go into the details of this sharding, but if you suppose if this is a ACI troubleshooting class, definitely I'll go for what is the sharding and how the sharding works. But I'm not taking troubleshooting classes, ACI troubleshooting class. This is not part of our curriculum, data center version 3.0 curriculum also. Yes, but APIC troubleshooting, I'm going to explain you, which is very, very important. That is, in case if one APIC fails, then what happens? But sharding is something which is covered over there. Any other question, guys? We still have time. You can ask the question or you can type the question. I am looking at into the chat window also. Okay. So, Amit, Kumar. Yes. Okay. Guys, all right. If no question, then let's wind up for the day. Thank you so much for joining. Hope to see you tomorrow as well. The same time, 9 o'clock. Slowly and slowly we will move, but would request you, please don't miss even a single class. Each and every class is interrelated and very, very important. If you miss any class or if you feel that you are missing any class, please let me know. I will share the recording with you so that the next class should not be something new. And there are a lot of labs also. Labs require your tremendous attention, and of course before the labs you really need a good theory understanding as well. So tomorrow we are going to discuss about the APIC control plane protocols. What are the significance of those protocols? How the communication flows from the controller to other devices, say leaf to spine, etc. There are a lot of protocols, very important, but don't worry, we need not configure any of the protocol. APIC is basically ask us to configure the last configuration, not to create the fabric. Fabric gets created automatically, but our basic activities are required there. Seems there is another question. All right, no problem, Jay. But you joined early. Okay, fine. Okay, guys, no problem. Thank you very much. We are winding up for the day. Wish you a great day. And please, please, please stay safe, stay healthy. Very important. Don't be afraid of the current situation, but just be conscious about it. Thank you very much.